One day, the sun will rise for the last time. Not because it explodes, not because it suddenly disappears, but because it changes. And that change will make Earth unlivable long before the sun actually dies. The sun is not permanent. It is not eternal. It is a system, powered by fuel and governed by physics. To understand how the sun will die, you must first understand how it lives. The sun is not fire. Fire needs oxygen. The sun has none. Instead, it is powered by nuclear fusion. At its core, temperatures reach over 15 million degrees Celsius. Hydrogen atoms are crushed together under immense pressure. Normally, they repel each other, but inside the sun, quantum tunneling allows them to fuse. When hydrogen nuclei combine to form helium, a small amount of mass disappears. That mass becomes energy. This is why the sun shines. Not because it burns, but because it converts matter into energy. But this process cannot last forever. Every fusion reaction leaves behind helium, which does not fuse easily at current temperatures. Over time, helium builds up in the core, like ash in a fire. This changes everything, because the sun depends on its core to produce energy, and now the core is slowly filling with unusable material. As helium accumulates, gravity compresses the core further, and when matter is compressed, it heats up. This rising temperature increases fusion in the surrounding layers, so instead of dimming, the sun slowly becomes brighter. Because Earth depends on a very delicate energy balance, even a small increase in solar output has massive long-term effects. Over hundreds of millions of years, higher temperatures speed up chemical reactions between rainwater and rocks. This process removes carbon dioxide from the atmosphere. And carbon dioxide is not just a greenhouse gas. It is food for plants. When CO2 levels fall too low, plants can no longer perform photosynthesis. Without plants, oxygen levels drop. Food chains collapse. Complex life disappears. And this happens long before the sun dies. As temperatures continue rising, the oceans begin to evaporate. Not suddenly, but steadily. Water vapor enters the atmosphere, and water vapor is a powerful greenhouse gas. It traps heat more effectively than carbon dioxide. This creates a feedback loop. More heat causes more evaporation. More evaporation traps more heat. The system spirals out of control. Eventually, ultraviolet radiation breaks water molecules apart in the upper atmosphere. Hydrogen escapes into space, and once hydrogen is gone, water can never reform. Earth loses its oceans forever. At this point, Earth becomes a dry, overheated world, similar to Venus. Surface temperatures rise to hundreds of degrees. The atmosphere becomes thick and hostile. Life is gone. And still, the sun continues. Billions of years later, the core finally runs out of hydrogen. Fusion in the core stops. Without outward pressure, gravity takes over. The core collapses inward. But this collapse increases temperature dramatically, hot enough to ignite fusion in a surrounding shell. This releases even more energy, and that energy pushes the outer layers outward. The sun expands into a red giant. It grows over 100 times larger than its current size. Its surface cools slightly, giving it a reddish color. But its total energy output increases. Mercury is swallowed first, then Venus. Earth's fate is uncertain, but survival is unlikely. Even if it escapes being swallowed, temperatures will melt the surface into magma. Eventually, the sun sheds its outer layers. They drift into space, forming a glowing shell of gas, a planetary nebula. At the center, a white dwarf remains, a dense, hot stellar core, no longer producing energy, only slowly cooling over time. This remnant is supported by quantum physics. Electron degeneracy pressure prevents it from collapsing further. Over trillions of years, it fades, becoming colder, dimmer, until it is no longer visible. So can we stop this? No. The evolution of a star is governed by fundamental physics. It cannot be stopped. But survival may still be possible. One idea is to gradually move Earth outward. Using gravitational interactions with asteroids, we could slowly increase its orbital distance. Another idea is to build massive solar shades in space, reducing the amount of sunlight reaching Earth. We could also artificially maintain atmospheric balance, keeping carbon dioxide levels stable to prolong plant life, or move life underground, where temperatures remain stable for longer. But eventually, none of these solutions are permanent. The most realistic long-term path is to leave, to spread beyond Earth, beyond the solar system, because the Sun is not unique. Every star follows the same fate. The Sun is not our enemy. It is simply following the laws of physics. And the real question is not whether the Sun will change, but whether we will before it does.